Okay, time to step out of our book for a little while and go through integers. Integers are all positive and negative numbers. We looked at them when we talked about like absolute value. We talked about number lines. When we were plotting coordinate planes, we talked about positive and negative numbers. So we've looked at them already, but we haven't done math with them. We haven't done the functions of math, which is once again adding, subtracting, multiplying, and dividing. I teach integers usually in reverse compared to many other teachers because I like to start with the easiest ones and go to the more complicated ones. So we'll start today in the first lesson with multiplication and division. They are the easiest ones to do. And then we'll go to the multi-step ones with addition for our second lesson. And then we'll get into subtraction because the subtraction has multiple steps and is a little bit more complicated. If you think back to when we did fractions, we always started our fraction questions with, can I add fractions? Can I subtract fractions? Can I multiply fractions? And in all of those, we said yes. But then we got to, can I divide fractions? And the answer was no. Integers is the same way. Can I multiply integers? Yes. Can I divide integers? Yes. Can I add integers? Yes. Can I subtract integers? No. And because of the no, I wait until the third lesson on integers to introduce that. So when we talk about integers, once again, we're talking about all positive and negative numbers, and those can be whole numbers, they can be decimals, they can be fractions. So I'll be doing some spiral review on these questions and during these packets just to review how we do those extra things like multiplying fractions or dividing fractions. So let's get into the questions in which we need to ask when it comes to multiplying and dividing. Notice I put a slash there for multiplying and dividing because they're actually the same questions we're going to ask on both types of problems. And that question is always going to be, can I multiply integers? And that's a yes. My first step will always be the same. When I'm multiplying or dividing, I'm going to do the math. And here we're multiplying. So we're going to always have two math numbers in these particular problems, and we're going to multiply them together no matter what. Multiplying whole numbers, multiplying decimals, multiplying fractions, we're going to do the math. I ignore the integers. Integers, once again, is the positive and negative sign. Once I get the answer, once I get the product to the multiplication problem, then I look at the signs. So if I have the same sign, meaning if I have a positive and a positive, or I have a negative and a negative, then that answer will always be positive no matter what. If I have opposite signs, I have one negative and one positive, and it doesn't matter the order that they go in. The first one could be negative, the second one could be positive, or the first one could be positive and the second could be negative, then I know my answer is going to be in the negative form. So what that looks like, instead of just words, we're going to work through some problems. So on this first one, we're going to start in the top left and then go across. We have -6 times 7. So there's some things I'm going to ask you to do and suggest that you do to make your life easier. And it's students that are going to not want to put in the extra step of showing the integer sign of positive that have a tendency to mess these up. So I would always suggest that you show that. But once again, my first step is always going to be multiply. And 6 times 7 is 42. Now you can stack them and show your work, or most of you are going to know that 6 times 7 is 42. You can even use your handy dandy calculator and find out that 6 times 7 is indeed 42. But with integers, this is where I have to know what my second step is. So locating the sign, locating the integer sign of the number. Notice the negative is in front of the 6, and then I circled an empty space on the 7. Once again, I would strongly suggest that you do this step. If it is a positive number, I would strongly suggest that you circle it and add the positive sign. This way, you are not going to be confused at all that that's a positive number. It's the students that try to take the shortcut and not ever show the positive sign that they start getting confused when they start doing all of these different math functions over the next 3 lessons. So take that extra quarter of a second and put a circle and add an addition sign or a positive sign for the 7. Now, once I notice the two signs, then I go back to step 2. Do I have the same sign? Do I have 2 positives or 2 negatives? And that answer is no. They are opposite signs, so my answer is automatically going to become a negative. So my answer becomes negative 42. Going straight across, I ignore the integer signs and I look at the math. I have 7 times 3. That takes us back to 3rd grade math. Well, 7 times 3 is 21. Now I have to look at the signs, and once again, I don't have a positive sign there. Sometimes I will, and sometimes I won't. It just depends on the worksheet or the problem that you're working on. Sometimes they won't have the positive sign, and sometimes they will. If they don't, I strongly suggest that you put it there. And then we circle the 2 signs so I can focus in and figure out what my answer needs to be, or what form my answer needs to be. I have them both circled so that I look, are they the same? They're not the same. So I go to the 2b. They are opposite signs, so I know I'm going to have a negative 21 as my answer. Now on the bottom left, sometimes when we see these, we're going to have parentheses. The parentheses are not connecting numbers. They're not connecting variables. They're not showing any extra math. They're really just there to separate the integer sign from the math function sign. So notice that it separates the multiplication and the negative. So it doesn't change the math at all. You can just pretend that they're not there, and you would see that it's 6 times negative 10. So I still start with step 1. I multiply. Well, 6 times 10 is 60. Now I locate my integer signs. Well, once again, add that positive sign for 6, circle it, and then you're going to circle the negative on the 10. Since they're both circled, I look at them and I compare them. Are they the same? They're not the same, so I know they're opposites. Therefore, my answer has to be negative 60. Same signs are positive, opposite signs are negative. Now on the bottom left right one then, we have a floating dot. So I'm going to be showing you different ways that we can show multiplication and different ways to show division on these math problems. So it's just my way of showing you different ways that you might see it on the iLearn or NWEA or any other standardized test that you might arrive to. So multiple ways of showing multiplication, but it simply means to multiply. So I know I'm going to do the math, which is step 1. 3 times 5 is 15. Now I look at my signs. I circle both of them. Are they the same? They are. So since they're the same, then I'm doing what would be 2a, and I'm going to make it a positive sign. So my answer has to be positive 15. I'm not going to count it wrong if you only put 15. I don't believe the iLearn will count it wrong if you put a positive 15. I know NWEA doesn't count it wrong if you don't put a positive 15, because 15 without a positive sign is still positive. However, we're going to be doing a lot of different work with positive and negatives, with integers, and I would strongly suggest you start showing the positive or the negative sign with your answer so that you can do these problems that we're going to be doing that have 3 and 4 steps to them and not get yourself confused. All right, so we have a couple more practices. So we're just going to work down the bottom right-hand side, and then I'm going to leave 3 on the right-hand side in case you have some extra questions and need additional help. These are all still multiplication. We have the floating dot, we have the asterisk, which means multiplication, and we should know by now that the word of also means multiplication. So I look at it, and I still start with the math. 11 times 12. Well, when I stack those, then I can do 11 times 12 if I don't know my multiplication facts. And most people don't know these double digits as well as they do like 6 times 7. So I start with the 1 in the bottom right-hand corner, and I have 1 times 12, which is going to give me 12. My second number tells me to bring down a 0, and then I multiply by my second number. And 1 times 12 is 12 again. So when I add those together, I get 132. So I did the math, but now I need to know what my sign is. I locate the signs in the math problem, and I notice they're both negative. Same sign tells me that my answer needs to be in the form of a positive integer. Going to that middle one then, as we said, the asterisk means multiplication, so I go back to those original questions that we did early on in the book. Can I multiply fractions? And that answer is yes. Then we said, how do we do it? And we say, well, we're going to multiply across. So I'm going to get my numerators of 3 times 1, which is 3. I'm going to get my denominators of 4 times 2, which is 8. And then I look at my signs inside my math problem. I have a negative and I have a positive. So when I look at step 2, my opposite signs, I know that has to be a negative 3/8. Multiplying decimals. Can I multiply decimals? Yes. What do? I do the math first, then I count decimal spaces. So when I stack them, then I'm going to multiply, and I have 7 times 16, which is 112. Now, don't just bring down your decimal, because that's going to end up with 11.2, which is not the answer. We count decimal spaces with multiplication of decimals. So I have 2 decimal spaces. So that tells me I have to move from right to left 2 times to place my decimal, which gives me 1 and 1200ths, or 1.12. Then I locate my signs. I have a positive and a negative, opposite signs, so my answer has to be in the form of a negative. All right, so that's our introduction to multiplication. Now let's take a look at division. So we're going to ask ourselves, can we divide integers? And that question, or that answer, is yes to that question once again. These are the same steps as we do on multiplication. So my first step is going to be to do the math. My second step will be the same. I'm going to look at my signs, circle them. If they're both positive or they're both negative, then my answer has to be positive. If one is positive and one is negative, then my answer has to be in the form of a negative number. Let's look at 4 examples. So I have 55 divided by 5. So these are all what we refer to as division number sentences because they go from left to right. When I do these then, if I'm going to use a division box, then I'm always going to put the first number inside the division box. If I'm just simply typing them into a calculator, then I take the first number and type it in first, then the division sign, and then the 5 equals. When I look at my division then, I should probably know that 5 will go into 55 11 times. If I don't, then I can divide it out, get my handy dandy calculator, or do a division box. When I get 11, then I need to look at my signs. So I have a negative on the 55, but there's nothing on the 5. Once again, that's an understood positive. So when I have them both circled, then I look at them. Do I have the same signs? No, I have opposites. So since they're opposites, my answer has to be negative 11. How about going straight across to 63 divided by 9? Step 1, still I'm going to do the math. 63 divided by 9, well, that's 7. I find my signs. I have a negative and a positive. Opposite signs tell me my answer has to be in the form of negative 7. Once again, in the bottom, with division, the parentheses are not doing anything special to the math. They're just separating the integer signs from other numbers or other symbols. So if I just ignore the parentheses, then it's just negative 6 divided by negative 3. I do the math. 63 divided by 3 is 21. 3 goes into 6 twice, 3 goes into 3 one time. Then I look at my signs. Do I have the same signs? Ah, this is my first one I do. I have the same sign, so I know my answer has to be in the form of a positive. Once again, I won't count it wrong without the positive sign, but I would strongly suggest that you start showing the positive sign so you don't mess up when we get into harder problems and we start getting into inequalities. All right, so then I have negative 8 divided by 2. Once again, I ignore those parentheses. It's not changing my math. I just do the math, and 8 divided by 2 is 4. Now I look at my signs. I have a negative and I have a positive. On the 2, it's an understood positive. They're opposite signs, so I know my answer has to be in the form of a negative 4. Just like in multiplication. All right, so doing the bottom 3 on the left, just like we did in multiplication then, I have 3 different division problems here. Now notice that the bottom one looks like what we have been doing, but we have a fraction and then we have that slanted line. So as we said in the first unit, we said that all fractions mean division. And when we set those up in a division box, the numerator, the top number, always goes inside the division box. The bottom number, the denominator, is always my divisor. So the top number is the dividend, bottom number, divisor. The slash in the middle there also means division. Basically what that is a fraction that's laying down sideways. The first number would still be considered the numerator. The second number would still be considered the denominator. And I would still stack up my division box the same way. So I'm going to start with 144, going inside the division box, and I'm going to divide by 12. Once again, I'm doing the math first. I'm ignoring the integer signs. 12 goes into 144 12 times. Then I look at the signs. Notice that I have an understood positive for the 144 with the negative. So step 2, opposite signs, I know I have to have an answer of negative 12. In the middle one then, 615, first number goes inside the division box, divided by the 5, ignoring the integer signs. 5 goes into 6 one time, and then we'll go into 11 twice, then we'll go into 15 3 times. And if I type in 615 divided by 5, I'm going to see 123. I look at my signs. An understood positive, once again, with that first number, and a negative with the second. Opposite signs tell me that my answer has to be negative 123. And then we have dividing decimals. So dividing decimals, we have the first number, once again, always inside the division box, divided by 1.1. But then I have to review my questions on dividing decimals. Can I divide decimals? And that answer is no. I cannot divide with a decimal. I can only divide if that's a whole number on the outside as the divisor. So I have to go through those 3 little letters, the OOU. I'm going to go over on the outside until it's a whole number. In this case, I only need to go over once. I go over on the inside the same number of times that I did on the outside. I went over once on the outside. I'm going to go over once on the inside. And then I would raise it up. But when I divide it out, I find out that that's a whole number and I don't need the decimal because 11 times 11 is 121. So 121 divided by 11 is 11. When I look at my signs, though, I have 2 negatives. So that tells me that this answer has to be in what form? Hopefully you said positive. All right, so that is our introduction of integers for positive and negatives when it comes to multiplying and dividing. So you're going to have 20 questions to do. You're going to have 10 that are multiplication and 10 that are division. Remember on these, when I ask the question, can I do this math? Can I multiply or divide integers? That answer is always yes. And my first step will always be to do the math. I will multiply first or I will divide first. Then I have to look at my integer signs. If I have 2 positives, my answer has to be positive. If I have 2 negatives, my answer has to be positive. However, if I have opposite signs, one positive, one negative, then it has to be a negative answer.